Alright, we're going to look today at solving absolute value and inequalities, specifically compound inequalities. Alright, so if you remember, absolute value is our distance from 0. For example, absolute value -4 is 4. And a compound inequality is where we have two inequalities combining for one variable, one expression. If we look at the graphs, especially for the inequalities, if we start at -4 and 6, we're looking for the numbers that are greater than -4 and less than 6. Greater than or equal to -4 we symbolize with our closed circle or filled in circle. Alright. So here's an example problem. If we want the absolute value of quantity 2x plus 1 to equal 5, well, if we think about what that looks like on our number line, something in the absolute value has to equal either -5 or 5. Those are the only two numbers that give us a distance from 0 of 5. This is going to give us two equations. The first one is 2x plus 1 equals -5. The second one, 2x plus 1 equals 5. Now that we have our two equations, we just go through and solve them as we normally would for any linear equation, and we get x equals -3 or x equals 2. And we could check that by plugging back into our original equation and making sure that we actually get a value, an absolute value of 5. Okay, if we're solving inequalities, let's take a step back and think about what happens to a true statement when we do certain operations on it. So 2 is less than 3 is a true statement. We have different operations, and the sign of that operation produces different results. So if we multiply by a positive number, the result is the inequality stays the same. It's still less than. If we multiply and the sign is negative, so multiplying by -2 or -3 or -8, what happens is our sign is going to flip. And same thing with division. If we divide by a positive number, our sign stays the same. If we divide by a negative number, our sign is once again going to flip. So here's an example. 4x minus 3 is less than or equal to 13. So we solve it as we normally would. We add 3 on both sides, and then we're going to divide by -4 on both sides. And since we divided by -4, we're going to have to flip our value. Alright, so we get x is greater than -4, and we would graph it on a number line with a closed circle going an arrow to the right. We could check that. An easy number to check would be to put in 0. So we put in 0. -4 times 0 is 0. Minus 3 is -3. -3 is in fact less than 13. So we're all good. Okay. It gets a little bit trickier when we're talking about compound inequalities. So again, a compound inequality is more than one inequality. So if we are given a graph, we want to first off just read, what is this saying to us? Well, this is looking at the numbers that are greater than or equal to -3, but also less than 5. Alright? So numbers that are less than 5 and greater than or equal to -3. Well, we could write that as an equation, as an inequality. So we combine the two, and we would read the purple statement as -3 is less than or equal to x, which is less than 5. The numbers, we in this case are using a variable to represent. Alright? What if the arrows went the other way? Well, this we would have -3, numbers that are less than -3, or numbers that are greater than 5. And we're going to see a big difference between two little words. So we have the words or, and we're going to have the words and. And this one we can't combine into one full statement like we did at the top. We actually have to use the word or. Otherwise we'd have conflicting inequalities. Okay. So we have and and we have or. The one on the top is and. It's more restrictive. They both have to be satisfied. Those are numbers that satisfy both of them. We call that the intersection if we're using our set notation. Or is the union. Alright? Symbolized with the U if we're using our set notation. So let's look at how it looks when we solve this. Absolute value of x is less than or equal to 10. Well, we know that what has to be in the inequality has to be either 10 or negative 10. Those are the only numbers that have an absolute value of 10. And we want values that are less than that. So we could look at our graph and we could just interpret it. Try to figure out, oh, what are some numbers? Negative 1 is going to have its absolute value less than 10. 0, 1, 2, 3, 4, 5, all those numbers in between. We could also do this algebraically. So we would be given two equations. One is just dropping the absolute value sign. The other is putting our negative sign in front of, taking the opposite of what's in the absolute value. Alright, we solve them, and we solve that when we have to flip our inequality. And if we were to graph those two, we would get the picture above. Let's take one that's a little bit more complicated. So absolute value of x minus 5 is greater than 6. Well, we know what has to be in the inequality. The absolute value is either 6 or negative 6. Those are the only numbers that will work. And we're going to look for numbers that are greater than it. So if I had negative 7 in the absolute value, that would work. Negative 20. If I had 20, 21, 22, absolute value of all those numbers would be greater than 6. Let's look at it algebraically as well. We know that our equation has to work like that, and so we're given our two values there. Alright, but we could do it algebraically again as well, and we should also plot our solution. So the true solution is just where x is isolated. Alright, algebraically again we're going to get our two equations. First is just dropping the absolute value sign. The second is taking the opposite of what's in the sign.